What's up guys, it's Kevin, and today our ACT math lesson is going to be over simple probability. So simple probability is just one of those things that are lightly tested on the ACT, not very heavily focused on simple probability in specific. It goes in depth with conditional probability and independence, and just for the sake of time today we're going to be going over just simple probability, and for later videos we'll be going over the advanced probability questions. So to get a firm understanding of what simple probability is, it's the likelihood of an event given a certain circumstance. So probability is always going to be a number from 0 to 1, and it's usually in the form of a fraction or a percentage. And so an example of this would be picking a king out of a deck of cards. Say you're given this question, you want to look at all the variables that come into play. So the total number of cards here is 52 cards in the deck, and there's 4 kings in total. So you're going back to this probability equation, which is the probability equals the number of the desired outcome over the total number of possible outcomes. So our desired outcome is 4, as there's 4 kings, or we're trying to find the probability of picking a king, and the total outcome is 52. So when we set this equal to a fraction, it's 4 over 52, which simplifies to 1 over 13. So now we're going to be going over a couple questions from practice test 1 released by the ACT. I highly encourage you guys to pause at this time and really attempt these questions so you know what you're struggling on personally and what you can improve on. Alright, so we first want to start off reading the question carefully, just underlining or highlighting anything we find could be of importance here. So starting off, the 35-member club is meeting to choose a student government representative. So they're choosing a single student government representative, and we can figure that out by the singular representative and the letter A here. So the members decide that the representative will be chosen at random. So chosen at random, that implies we're going to be using probability. Cannot be any of the 3 current officers of the club. So that already limits us down to, from the 35-member club, to 3 of those cannot be one of those chosen. So what is the probability that Hiroko, who's a member of the club, non-officer, will be chosen? Alright, so let's go back to our probability equation. And so our desired outcome is going to be 1, and we know that from a student government representative and Hiroko. So Hiroko is just one of those, so we're trying to find the probability that he is chosen. Probability of Hiroko is 1 over the total number of possible outcomes. So how many members are in the club? There's 35 members in the club. But remember, they said cannot be any of the 3 current officers of the club. So we subtract 3 from that, and the total outcome at the bottom is 32, and 1 over 32, that gives us answer choice K. Alright, going on to our second example. This is also from practice test 1 released from the ACT. And again, I encourage you guys to work through these by yourselves and pause the video. So again, going back to our strategy, read the question thoroughly, and I cannot emphasize this enough. You guys don't want to get a score that you guys don't want to miss out on the score that you're aiming for because of a silly mistake. So, a wallet containing 5 $5 bills, 7 $10 bills, and 8 $20 bills is found and returned to its owner. So we know 5, 7, and 8. We want to write that down just to keep track of everything and not lose track. 5 $5 bills, 7 $10 bills, and 8 $20 bills. So the wallet's owner will reward the finder with 1 bill drawn randomly. 1 bill drawn randomly. So we know we're working with probability, hence the term randomly, and 1 bill. So that's one bill drawn randomly. What is the probability that the bill drawn will be a $20 bill? So we want the probability of a $20 bill, and referring back to the original equation of probability, the probability of getting a $20 bill is going to be desired outcome over total outcome. So our desired outcome is the $20 bill, and how many total $20 bills are there? There's 8. And we wrote that down, so that makes it a lot easier instead of having to refer back. So 8 $20 bills over the total number of bills. So we're picking from the wallet randomly, so it's going to be any of the bills. So we're going to count the total number of outcomes, which is the total number of bills. So it's going to be 8 plus 7 plus 5. So that comes out as 8 over 20. And none of these answer choices show 8 over 20, so we can reduce this to 2 over 5. And that leaves us with answer choice D.